Hello, so this is a revision video for AP Chemistry 8.11, pH and solubility. The pH of a solution can influence the solubility of a salt if the salt contains a basic anion, so a conjugate base of a weak acid, a cation that acts as a weak acid, for example an ammonium ion, or it contains hydroxide ions. We can explain such changes in solubility in terms of Le Chatelier's principle, covered in topic 7.9. Le Chatelier's principle states that a system at equilibrium will adjust to minimize the impact of a disturbance or stress. For example, when sodium fluoride dissolves in water, an equilibrium is established between NaF, Na+, and F-. Because F- is a basic anion and the conjugate base of the weak acid HF, it can react with hydronium ions to form HF and H2O, forming an equilibrium system. So if a solution of sodium fluoride has acid added to it, the added H3O+ ions shift the position of equilibrium to the right. More F- ions react with added H3O+ ions to form HF and H2O. This then means the concentration of F- ions in the solution decreases, so the equilibrium for the original dissolution of the salt shifts to the right. More NaF dissolves in solution to replace the F- ions that reacted with the added H3O+ ions from the acid. As a result, the solubility increases in acidic conditions. Equally, if more base was added, so raising the pH by adding hydroxide ions, now the opposite is true. H3O+ ions in the solution will react with the added hydroxide ions, therefore shifting the equilibrium position for the dissolving of NaF to the left. Less NaF dissolves, meaning the solubility decreases in basic conditions. The same thing can be seen with metal hydroxides, for example iron-free hydroxide, FeOH3. The iron hydroxide forms an equilibrium when it dissolves with Fe3+ ions and hydroxide ions. If the pH is lowered by adding more acid, added H3O+ ions react with the OH- ions, decreasing the concentration of OH-. To counter this decrease, equilibrium shifts to the right, meaning more FeOH3 dissolves and the solubility increases. Equally, if the pH of the solution is increased by adding more OH- ions, this increases the concentration of OH- ions and the equilibrium shifts to the left. This means more OH- combines with Fe3+, and more solid iron hydroxide is made. The solubility decreases. Exam tip here. pH doesn't affect solubility if the ions in the salt are from strong acids or strong bases and don't react further. For example, Na+ and Cl- ions are both conjugates of strong acids, HCl, and strong base, NaOH, and they are spectator ions, so pH doesn't change the solubility of NaCl.